Okay, this is just a little test, informal test, to answer the question, where does it lose the angle? Most phase angle measurement instruments seem to go away at low amplitudes. You know, they get down to below 10% of scale and the angle starts to go all over the place. Well, not a CTMP. Here I'm testing an 8000 to 5 standard. I'm using very low excitation, 10.5 volts, and the volts in off the one-turn primary is 6.6 millivolts. That's on a 300 millivolt full-scale input. So now I can go down a little bit at a time here. Nine and a half. Angle's still right on. Ratio is still within 0.1%. Angle's still right on at 5.3 millivolts. Ratio is a little bit out of 0.1% at that point. Okay, below 5 millivolts, the ratio no longer shows because you don't want noise or an error confusing people. And almost any CT will give you 5 millivolts. Okay, but you notice the angle is still on. Still right there, fairly stable at 359.96. Let's go even lower. Let's go to 4 volts excitation. Now here, any other phase angle instrument would lose the angle. You know, you couldn't, it'd be all over the place. And just to show that it's not stuck or something, I'll go ahead and swap the leads momentarily here. And you can see that swap the leads, you get 180 out like you'd expect. Put it back in. Okay, so we'll go lower here. Let's go down some more. Let's go down to 0.7 of a volt. See, we're starting to get a little noise on the angle, but it's still certainly within a degree. So that kind of demonstrates just how low you can go and still read the angle. Others, your normal establishment type of test equipment manufacturers can't do that. Right now we're about 120 microvolts. You can still tell the polarity right there. That's how awesome it is.